Yeah, hello, good evening all.
Good evening, ma'am.
Yeah, good evening.
Yeah, our host and co-host sir is joining. Coordinator and co-coordinator sir is joining in a while.
Okay, sure. Yeah, good evening, sir.
Good evening. How are you?
Yeah, sir, I'm doing good. Hope you're doing good
Okay.
too.
Okay. Great.
Yeah,
The
so,
previous session was a bit uh, delayed and overshot. So maybe
okay.
5-6 minutes it was there.
Yeah,
Sorry, I
yeah,
had
I
to
was,
wait at the lobby. I mean, yeah.
no,
Uh,
sir. I was just thinking like whether I joined the right link or something. So I just confirmed. Yeah,
no, that's perfectly all right. That's perfectly all
yeah,
right. Only thing
yes.
that, yeah.
Hmm. I
So
think
where are you now? Are you at Hyderabad?
yeah, sir. I joined back work.
Oh, you joined back work when?
Just the last week only, sir. It's been a hectic week.
Oh, I see.
Yeah,
So, so, so your vacation is over.
yeah. Yes, sir.
All right.
I
How you are liking back to the office?
Yes, sir. I think it is a good change. It's like not feeling good staying at home. Also, that I think
Yeah.
the transition was required. Yeah,
Okay.
yeah. It was unexpected. I was thinking of joining quite later, but then I got the call from the office. They themselves wanted me to join because we got a
Hmm.
similar project. So they
Oh,
want,
I see. I
yeah.
see. I
So
see.
they
I
were
see. I
like,
see.
okay, rather than
Okay.
like taking somebody new and giving them the same thing.
Naturally, but
Yeah.
and one more thing, you have the option or at this thing scope to work from home also partly.
Other, I think in the industry, it's only allowed till your child is like 1 year old. So I think that I lose in another 2 months.
Oh, I
Yeah.
see. I see. But then but in the IT area or some okay, no, even that's a different thing.
Yeah,
Yes.
unless
Of
until
course,
the
you have to
project requires us to work from like that could be an
understand.
option. Yeah, that could be an option if they are just now, reviewing the laptops will be coming from another client. So if the Wi-Fi doesn't work in the office, so they have to do something like that, remote working options. Yeah. So these things are still going on process.
Fine. Okay. I think Professor, I will now take over.
Hmm.
Uh, so yeah, nice to see you after some time, quite
Yeah,
some time.
yes, same here. Yes.
Thank you,
All the
sir.
very best. Yeah.
Yeah.
Thank you, sir. Already sorry for the delay actually.
Yeah, I
So,
know.
Dr. Yeah, Dr. Shirisha Tamada. So, good evening again for the second session, all the
Yeah.
participants.
Good
And
evening.
Dr. Shirisha Tamada is there. So, before that, let me introduce Dr. Tamada to our participants. He is presently working in Tata Consulting Services involved with modeling, simulation, and process improvement of automotive systems. She previously worked as a senior assistant professor in Automotive Research Center in Belur Institute of Technology. Dr. Sirisha has completed her PhD from Indian Institute of Technology, Kharagpur, where the research focused on modeling and control of automatic transmission system. So this is a short bio profile of Dr. Sirisha Tamada. Now, Dr. Tamada, session is yours. You may continue.
Can I share the screen right now, right?
Yeah.
Just give me a second. I'll just,
Okay.
yeah. I think entire screen. Okay. Yeah, is my is visible?
Yes.
Okay, I'll just it's taking a lot of bandwidth. Yeah. Okay. So good evening to all of y'all, and I'm here, Dr. Sirsha Damada, here to present my topic on automotive systems. Basically, like the work which I have done in the past few years in my company, the recent companies I've joined. I tried to assimilate so that you can get a little bit of the industry perspective of what is going on, and I'm happy that similar conferences are going on in the area of Industry 4.0. So I'll just keep it crisp. So there is a content flows in the order, like I'll talk a little bit of the Industry 4.0, and then we'll get into what actually ASPICE is and where both of these technologies converge, and what is ASPICE 4.0 for industry perspective. In my content, it will be more aligned to the automotive field, which I'll talk about. And we'll see go on the process what happens. Also, just before I dive into it, I'll just give a brief. Like when I joined initially, so my work revolves more around the modeling and simulation of automotive systems, and also controlling these features. So in the initial year, I worked mostly on developing the dual active bridge flyback converter. Okay, so that was a proof of concept kind of a work. So though those kind of details and the simulations we can't show you, but I can just throw some light upon what actually the industry is working on. So MATLAB Simulink is right now the hot cake. So anybody wanting to delve into automotive industry should be well versed with it. And once they develop the converters on a simulation level, and it is tested for in the level of model in loop testing, and then the hardware in loop testing, it is also going in for the initial testing process using whatever hardware is available on the microcontrollers, and then only you are able to get projects on a larger scale. So that's how when you are going to industry, that's how you have to show how you can get projects. So more or less after that project, I was much involved in the process improvement of automotive systems, where eSpice comes into picture, and it aligns well with this conference topic of Industry 4.0. So that's why I chose this for our session today. So I think by this time, all of you all must have understood like what Industry 4.0. I'll just quickly go through it. So what Industry 4.0 is mainly talking about, it's the digital transformation. So when we are using advanced technologies like Internet of Things, basically industrial Internet of Things, artificial intelligence, all of these technologies need to be used in the present whatever already existing technologies are there. You have to get these technologies into picture. That is what is bringing the digital transformation. And Industry 4.0 is what targets this kind of scope. And also apart from that, why we are calling it a smart factor, it's generally the convergence of both the physical and digital world. So whatever is happening at the manufacturing part, when you are involving all these technologies of Internet of Things or artificial intelligence, and now latest we have got Gen AI. So when you are getting these technologies into the picture, or when you are using analytics for processing or analyzing data, and uh, it is basically what it is doing is it is automating processes to some level. Okay, and so you are optimizing in the previous physical world, where the general kind of manufacturing process will go on, you are optimizing the time also, and it is much efficient is what it is found out. Similarly, when from taking from the Industry 4.0 perspective, when we come to specific automotive industry, so in automotive, you all know, just like now I talked about MATLAB Simulink and all. So even you have codes, right? You need to write codes for specific you know customer requirement that might be coming. I'll just throw a brief like to make you understand. So it could be something like voice summaries. I think you must be understanding what voice summaries are. So in software processes, it's always a hierarchy where you get some layman voice summaries from the customer, and then you have to understand how you can convert them into technical requirements. So you have to also assess whether they are feasible or not, and after that you create a document, and it's properly collated into a sheet where you convert these customer voices which you get into a specific requirement which can be implemented. How do you implement it? You do it with code, or you do it with simulation, whatever way. So when we come to automotive software processes, now we see that whatever automotive systems are there, be it the vehicles or any automotive system for that case, even Volvo trucks and all of those have also implemented software platforms within their vehicles. So nowadays you cannot say that the vehicles are any more mechanical at all. obviously the mechanical things are there, but it's mostly driven by software, like be it all the features like the traction control system, or you have anti-lock braking system. All of those things are backed by the software process. Even the advent of EVs which have come into picture, you have the battery management system which is again driven by software. So I'll just try to connect, and I hope you'll get the point where industry 4.0 and automotive software processes are coming into picture. So when you are taking these customer voices into picture and transforming them into feasible technical requirements, and then you assign groups who will be working on different, maybe some teams will be working on the braking, some on the battery and so on. So they will come up with their own results, right? And those, all of those things has to be collated into a specific place when you have to bring the final system into picture. So you have these software processes which needs to have some kind of a what I can say, some kind of a disciplined approach is what I can say. A disciplined approach is required so that these software processes can be implemented in a standard way. So industry 4.0 is also what it is new technologies that are coming into picture, but with certain kind of standards which they have already provided. So when we come to software processes also, there is like uh, the need or implementation of new technologies that needs to come into picture, with the relevance keeping into like a common standard which will be followed across all the automotive systems in the industry. So I'll just read out what is here. Like modern vehicles have transformed from mechanical systems into software-driven platforms, where sophisticated software controls everything from battery management to autonomous driving. Yeah, in autonomous, it's mostly software-driven. I don't think so. There's anything apart from the body and the wheels that is only a mechanical. So when software processes come into picture, that a lot of things come into picture according with that also. Like when you have internet of things, then comes the it becomes a cyber physical system. So when the cyber physical systems come into picture, you have cyber security. So all these things, it's like a subset it goes into, and then you need a certain standard. So when we have a software process happening in the automotive industry to drive all these new technologies to come into picture, we need to have a standardized process. I will come to that part in the next slide. So this software centric evolution, what does it make? It makes rigorous automotive software processes essential for several critical reasons. Yeah. So obviously, like you cannot compromise on the safety, or you cannot compromise on any of the what I can say, the cyber security leakage, or what you can say is the software cannot be compromised in any way. So it has to be rigorous in a way so that there is no room for any type of malfunction to happen. So how is that taken care of? At the higher level, you do make a simulation model, you do run it, you do make the codes and all, but how do you do it? That is what will come next. So I'll just throw a light upon. I think this all of you all must be aware of by now, like how industry 4.0 came into picture. I'm just throwing light upon this so that we can very well align with ASPICE, which I'll talk to you in some time. So in the first industry 1.0, we had the mechanization age and the steam power. Then the electricity, like power, came into picture. Then we had mass production and assembly line, where the utility of electricity could be made. And then we finally came on to digital revolution, where during that duration the computers came into picture. So we had programmable logic controllers and these systems where automation could happen to a certain extent. Now, since 2011, we have Industry 4.8, where even it is still in a continuing phase, where we are getting these technologies implemented, like automation, cloud, and AI, which I think it is an exhausting list which has not yet been fully captured, but it is based on Industry 3.0 itself, 3.0 itself. Okay, sorry. So when we talk about Industry 4.0, what it is basically talking about, it's talking about smart connected manufacturing, right? And when we talk about a smart connected manufacturing, and when we talk about all these key elements which I mentioned here, be it cyber physical systems, IoT, automation, cloud, or AI, how does it come into picture? in the automotive systems? Does anybody has an idea like how automotive systems have CPS, IoT, automation, cloud, or AI enabled? So simply like just now in the previous slide when I talked about autonomous systems. So autonomous systems, we all know that when you are implementing it in such a way that the steering should steer on its own without any human interference. So there is a lot of ECUs that are coming into picture, like right, and they are all controlled through one single monitor or a black box which is at the behind, and that black box collects continuously keeps collecting data that is stored in cloud again. So you are using some machine learning or any tool, specific tool to actually train this system to collect this data in real time, and also immediately make decisions. So it will be collecting data of images of what is ahead, if there's an obstacle or anything, and then these images are studied, and this is all happening in real time. So you have cloud coming into picture, you have the machine learning AI capability coming into picture, and then it is happening automatically with these industrial IoT technologies. And when all of these so many software things come into picture, cyber physical systems it is like a byproduct. Like you need to have some amount of you know uh, security which can counter these kind of cyber physical systems. So to counter all this, even in automotive systems, we have seen the advent of a standardized process, which like similar to the industrial evolution, we have seen that it also evolves from certain versions to now it is in line with industry 4.0 as ASPICE 4.0. Okay, so why I'm coming to this point is like I just wanted to support on this part where we talk about industry 4.0, and we talk about how it is having all these technologies in it. So how ASPICE 4.0 specifically will be supporting the digital transformation will gradually come into picture. Okay, so it is also a similar evolution from the predecessor, that is ASPICE 3.1. So when I talk about ASPICE, I mean it is automotive spice. Okay, like that is a standardized way they call it, and it is specifically designed to address the challenges and opportunities of the digitalized automotive landscape. This I just talked about some time back. So, like when I am talking about the Industry 4.0, this all key elements are coming into picture. So, you have a challenge. You have a challenge of how to tackle any flaws coming in, or any loopholes which could which could let sensitive data from a from the customer's automotive system to be leaked. This we don't want. And we have always seen cases, right, where we have seen the vehicles being called back. So why does all this happen? It was not happening in the advent when we had it totally mechanized. Now when you are getting software processes into picture, that is the time when you can see that there can be a lot of scope for lags or any faults to occur. And to mitigate all of that, we need a process which could uh, let you implement industry 4.0 keeping in picture. So that's where ASPICE 4.0 will come into application. So why we need to have versions for this also? You could have a point like the industry 4.0 evolution is a different thing, but ASPICE, if it is a standardized process for being implemented in a specific industry, then why do we need versions for that? Similar to industry 4.0, we also have technologies and inclusions of many other things coming into picture, which which needs the standards also to be broadened up. Like its scope needs to be broadened, and you need like the guidance should also be enhanced in a way that you can manage these modern automotive things like this CPS or IIoT, all of these things. How do you address these issues? You need to have a broader standard. You cannot go with the older ones. You can obviously go because when I'm talking about, it's an evolution from 3.1. So there are certain things which can be implemented from there, but you need to add on more. So now the machine learning is like into everything. So how do you standardize that thing also? So it is a kind of a scope where you are including so the major additions which have come from the previous ASPICE automotive spice 3.1 to automotive spice 4.1 is like there is a scope where we have included the hardware and machine learning part. So this though this whole A Spice 4 comes from the standardized process where all of the OEMs agree on this, and that is how you take it from the OEMs itself and you implement it when you are doing your own project. That is the main purpose. This is not like something you devise it on your own or anything like that. It is all the OEMs or OEMs, it seems, the original equipment manufacturers. That is what I'm talking about in automotive. So they have agreed upon this standardized. Okay. And what is the other things that we have added upon? Like you have enhanced maturity models for precise assessment. So you need to have you some kind of a markers. How okay, this kind of an assessment is good enough. So compared to the previous ones, the models here which have been used are much mature in its way of assessing the process. So that is also one of the benefits. And there is there when you I'll show you the picture in some time. So when you go to see the picture of ASPI 4.0, where you have various processes, you will also be amazed to know, like when an automotive system finally comes into picture, there are so many processes which come into action. Like there are many teams. So here the details have been improved much, and there is also immense number of roles also that comes into picture. So here they have enhanced the roles. What kind, like if I have to give a brief, it is more like uh, I won't say it as a haphazard way, but when you are working in an organization, uh, you need to assign certain tasks for certain teams with certain roles, right? But it's not necessary that every organization tends to follow that. But when you have this kind of a standardized process, and you make sure that when in your projects you implement this, so all of these disciplined actions do happen. So this basically leads to less ambiguity and more efficient systems that come into picture with lesser faults. Yeah, because we are including hardware and machine learning also in this version. So I talked about software processes. It's also written here that why do automotive software processes matter? They do matter because they ensure safety, compliance, quality, and scalability in an industry where software failures have life or death consequences. Like whatever I talked about, it is written here. So like if there is any failure in an autonomous vehicle, like how the result could be quite dangerous for even the person who could be in the vehicle or somebody ahead. So until and unless there is some way or some approach to how you ensure that whatever, like if there is no such measure, I feel that there'll be any other person on the road could be making an mini version of anything and keeping it on the road. But just because anything that comes into the market and it reaches the end user has to go through some benchmarks, it needs to be followed before it could be released to the market. So when in an automotive industry specifically, the safety is of priority, and then you need to see that whatever you are developing, before it reaches the end user, you are adherent with your compliance qualities, and how this similar technology, if it is foolproof, can also be scalable in this automotive industry. So how the ASPICE 4.0 is supporting this automotive software process? It is actually supporting the digital transformation which we are talking about till now in Industry 4.0. It directly supports digital transformation by going beyond the traditional software guidance only. So it is encompassing, like it is incorporating the hardware, machine learning, engineering, and it has also providing enhanced assessment tools. So the digital transformation which you are embodying in your specific component or whatever you are designing in your vehicle, that is not only going with the old traditional method, but it is including new technologies, and also that is assist. That is the main thing. Just using the modern technologies, learning them is a different factor, but on the higher level, it also needs to be assessed so that it goes through its thorough checks before being implemented. So when I'm talking about thorough checks, there could be a thought that could be coming into your mind that okay, when we are developing a model or when we are executing a code for a specific system inside the not system for a specific component, maybe for the BMS also. So it is already run, and you are maybe you're doing a pilot test on the hardware also, and you getting good results. But that is just the results which you are displaying on the smaller project that you are doing in the whole of the automotive system. But when the whole automotive system comes into picture, there are a lot of teams that work. So all of this needs to be collated, and then the result needs to be checked. And after the results are checked also, they are if the results are on par also, it needs to be seen whether the benchmarks that are set by the automotive standards, they are being met or not. So even for Industry 4.0, when you are bringing digital transformation, these challenges, how do each industry counters? They will be having similar approaches. In similar way, automotive industry has this approach of mitigating any failures at that way. So I'll quickly go to how Industry 4.1 is relevant in automotives. I talked about few of the things. We'll just read out what is here right now. In automotive manufacturing, the industrial IoT encompasses interconnected sensors embedded in machinery, production equipment, robotic systems, and material handling devices that continuously collect performance data, efficiency metrics, and maintenance indicators. So, I gave a short example for autonomous vehicles. Here, when you are using industrial IoT, here they're talking about the sensors which are also embedded in the machinery, and you have the product. So you are bringing internet industrial IoT also in the production equipment, also in the robotic systems which are making the automotive system, and whatever the material handling devices are there. Wherever you are getting these using sensors in all of these places, it will obviously collect keep on collecting data, which needs to have some metrics which can be a check for whether it is efficient, and whether it's on a maintenance level. So that is how Industry 4.0 comes into picture in automotive. Similarly, when we are talking about manufacturing, and then we go into quality control in automotive. So how these AI driven systems are there which perform real time defect detection. So the best example for that is obviously the battery management system, that you now know that when there are cases where it goes beyond a certain temperature, then mm, obviously it leads to fires and all those kind of hazards, even though we are having all these kind of mechanisms. So that is why a requirement to improve the quality control and improve manufacturing parts wherever Industry 4.0 comes into picture in any industry. Okay, so how are these AI driven systems performing real time detection? They are analyzing the production data, identifying the quality issues, so before any faulty parts progress down. So that is the norm in any of the industry. So you cannot get the fault to go down the stream when you have caught it upper somewhere. So like when you were already designing the code and you were executing it, and you already found some fault, so it cannot go to the next step. That is like a very normal thing that we all know. In quality control, even after sometimes even after you have cleared all of these instances, there could be some quality issue that assesses on the base that it could probably come to give a potential fault in the future. Even if that kind of an assessment comes into picture, then also the parts are not sent further for being implemented anywhere. So that is how quality control comes into implementation. So digital twins is also a very relevant concept taken from Industry 4.0 that it comes into picture in automotive. So you have a virtual model of physical manufacturing systems, and which revolutionize the automotive production planning and optimization. So here we have a very interesting example. I think I have read it somewhere from BMW, where they have used they could the employees could probably use the virtual reality devices they have provided them, and they can without even going to the factories and assembly lines, they can actually see how it needs to be worked upon and done. So rather than missing upon on that time which could be used in real time trading and all of that, and they learned the things much faster, and the work could be implemented into the assembly lines faster. So they had used, I remember they had used virtual reality devices, VRs, for the employees, so that the training can be in real time. So this is how digital twins and all of these are implemented in automotive part also. So this just gives a brief of where industry 4.0 is specifically coming into picture in automotive. So we'll dive into the main topic for the session today. So, what is ASPICE 4.0? I will try to give you an overview. So just I talked about like where you have releases from the previous versions here also. Like you had this had a 3.1 version before it, and so this is a very pretty much a very latest and a new version and a new technology. So it is like some of you, if you're passing out and going into the industry and joining automotive systems, they'll be happy about this. So it's just released in the December 2024, and just like we have ISO standards for a lot of things, so there is another standard which is also followed in automotive field, that is ISO 33020. So it somewhat aligns with that, but then automotive spice is mostly targeted to the automotive systems only. So you are assessing the process capability of developing like it is only involved with the process capability in the development of automotive systems specifically. So it can align with some other ISO standard, but it mostly deals with embedded automotive systems. So here what happens is in the 4.0 version, you see it covers software, just like I mentioned some time back. It covers hardware, it covers machine learning, mechatronics. So all of these concepts which have come into latest picture, and the previous versions were missing on this. So these are all been implemented. So it also supports agile form of development, and it is sticking on to the ISO 21434 cyber security standard also. So I just talked about like when you have a lot of interconnected systems and you have a lot of utilization of software processes into your system, that is basically usage of AI and all of these systems. So you need to have a strong cybersecurity system that is also coming up with some standards. So this also supports the same. Okay. So what is this diagram which I have just shown here? So the process assessment model, what we call as PAM. Okay, PAM model, which we call in ASPICE. So the PAM model basically it is a two-dimensional thing which you can see here in the picture. So in the other, like the two dimensions, one dimension is basically referring to the measurement framework, like what are the this is more like a measuring like what you can say is like a rating on a scaling basis, where you have some markers what I talk about. So this is one dimension that is there in the PAM model of eSpice, and the other dimension is where you assess the processes which is coming into a picture. So that is again referred to as process reference model. So you check like to specific process, what is the domain and what is the scopes, what is its purpose and what is the outcome. So that is how a PAM model comes into picture. So it has two dimensions here, one where you have some kind of a markers on either dimension, and the other is where you have a reference model so that you can assess that specific process. Okay. And so it has indicators which we see. So what actually is process assessment, if you have to understand? I have tried to mention it in the below text. Like process assessment model PAM functions by selecting processes from a standardized reference model. So that is one dimension which I talked about in the below. So it selects processes from already you have a standard reference models. So that is PRM. So from there it takes up a particular process, and that is how it is assessing. Okay, so that is how it functions. The PAM model basically functions on this whole aspect. Okay, and how do you make it into utilization? You have to have some kind of markers or indicators So that is the measurement framework here on the other side. So they are used for the objective evidence collection. So you need to also show like, okay, certain process area, if you are saying, okay, this is having some kind of a lag, or you cannot just say in words like, it is having a lag, it's having a fault. So and everything cannot be also written in text. When we have lot of processes, you cannot just keep on writing, okay, this is the fault, and when it goes a hierarchical level, on the top level, not necessary that all will understand like the technical aspects also. So you need to have a marker like, okay, this particular process, there are some benchmarks which need to be achieved and this is not being achieved, so you give a particular rating, or you give it a scale of something 0 to a 10 or something. So each rating has a certain meaning. So similarly, a person who is well versed with ASPICE 4.2 will get to understand, okay, what exactly the problem is, and okay, whether it needs to be taken ahead, or it needs to be resolved, or it needs to be totally removed before even being implemented in the automotive system. So this is how basically the process assessment model functions. Okay. And it enables the assessors to evaluate and assign appropriate capability ratings within the capability dimension framework. Okay, so this is what I just talked about. So like, you need to have a proper evaluation methodology by which you can assess the processes which are being used in the automotive systems with proper kind of measurement ratings or scalings which will be used. Okay, so basically, in automotive spice process, you have it contains set of indicators which you're seeing in the left. So these, which I told that needs to be found out. Like if a scaling has 0, then what does this mean and what it is meant. So what it means is like, you have to consider these ratings and you have to interpret. Okay, you have to interpret the intent of what this automotive spice reference model is trying to communicate. Okay, and you can also use these indicators when you have to, so that like if I have to make you understand in a very general way, so that it comes into the picture and you take something off from this course, from the session today, sorry. So I would like to tell that, like, if you have an organization where just imagine an organization where this A spice model has not been followed. Okay, like an automotive company XYZ. So they have been working in their own way, like maybe they'll take the voice of customers. They've developed the tech profile, like that is a technical requirement sheet, and then in that sheet they will be filling data. And maybe in a few other organizations they would not be having sheets and they would be communicating through mail. And they might not be having a proper assessment tool or methodology of what requirements should be taken and how to assess them, whether they are feasible or not. Okay, and then they would probably go with their own methodology. They could probably want to execute to what you can say, the code together and run it, and they would not go for a some other kind of checking. Like when you get the results, you need to have a back way, or what I can say, like whatever results you are getting, so you have to correlate with all of the teams, that it is aligning with all of them. It should not be something like, okay, you are doing one part of the work and you just concentrated with that, and you don't bother like whether the other part of the work is working out or not. So that is not how actually uh, a project can actually come into action. So how do you align all of these things? How, when you bring a spice into picture in certain situation, obviously you will have a standardized reference model. So they already have a reference to see how these whatever criteria they're taking, like even whatever tool they are using, even for the tool that they use, they will have an assessment model. Okay, this is for this certain kind of a task, for this technical requirement to be fulfilled, you need to use this kind of a tool, which is being used all over that organization. So you cannot just come around, okay, I want to use this and I want to do that. It's not like that. So that is where ASPICE comes into picture, and it gives you a standardized reference model. And when you have to back up your thing, the indicators or the markers help you. So that they serve as a measurement instruments, and they will help you to assess or evaluate. Okay, these certain things are which I have found out from whatever the customer's requirements are there, and these are all how I'm going to develop it, and through these markers, this is what I'm trying to tell my point. So that is how ASPICE 4.1, 4.0 comes into picture. Okay, so I think you have got a point. So automotive spice here, what you can see, it is having its own process reference model. So it was already previously developed, and now it has been further developed so that it can cater specifically to the needs of automotive industry. Okay, so but there could be a case also where the processes can be beyond the scope of automotive spice. That time, other reference models can also be taken into account, like other ISO standards are also added, so that whatever needs of the uh, automotive process is required, that can be fulfilled. So the organization business needs will be there. So if a certain kind of standards are not being covered, ISO also standards are also taken into conjunction with ASPICE 4.0. So I just talked about PRM and PAM some time back. I'm just throwing light upon. So don't get yourself into SIS 126, SWE 126. What is there? I'll just talk about it in some time. We'll just go through this once. So what are the main components when you are talking about ASPICE 4.0? It's a you need a process reference model, right? It is a you could also have that query like, okay, we have life cycle processes, all of these things. Like you could also have a life cycle management process which could replace this process reference model. But that is a different thing, altogether, when you are talking about life cycle process management. Here, when you take the process reference model, it is specific to the automotive needs. Okay, so you are not using anything that is apart from what is required. So here you make sure that what like here you if you have to just imagine like sys1 is like, you can consider it as system 1 to 6, or SWE as software requirements. So this is kind of processes which have been subdivided a lot into the automotive spice project. So each reference model is having its process ID. It will have its process name, and the purpose of why this process has been used, and what is outcomes, that is also been defined in each of this process reference model. Similarly, when we come to PAM, that is coming up from the process reference model only. What we are using for the why are we using the PAM model? It is using for performing any assessments of the capability of this process. So you need to assess. How do you do that? You doing that by performing some kind of an assessment here in the form of ASPICE, so that process's capability can be assessed, and you could develop embedded automotive systems to the best of the market requirements. Okay, so it is also developed according to the in accordance with the requirements of ISO standards. So as I previously discussed, if there is some of the standards which are not covered in ASPICE, then only further of any of the ISO standards are taken into picture. Okay, so when you come to process assessment model, as I told, that you need some kind of an assessment to also assess the capability of the process. That it has again some kind of assessments in the level of 0 to 5 capability levels. Okay, and this the PAM document which you have, that is a universal document for all the OEMs and whoever are working on automotive systems. It will give you all the necessary indicators. So in the previous slide where I talked about, so you have indicators here, like mentioned, the ratings, scalings, rating method, aggregation method. So all of those things, where you are actually using those indicators or markers, you're using it in work products, base practices, and resources. So what is work products? Basically, work products basically like even the voice of customers which you are taking, and you are using that as a uh, you know technical requirement document. So even the voice of customer could be a work product. The technical requirements could also be a work product. So all of those are also coming into picture when you have to have some assessment. Okay, so these are the so base practices of how. So in the PAM document they'll mention you, so okay, this is the work product, so how what it needs to contain and how it has to be. if base practice are mentioned, so for a certain process, like in the first line, how I mentioned is like systems 1 to 6. So there will be some demarcations of many system processes in different levels, and that will have certain kind of base practices that needs to be followed by each and every organization when you are performing any kind of code or any kind of function to uh, generate a kind of result which could be implemented in an automotive system. These things needs to be followed, and resources could be anything. It could be probably even the systems that you are using for designing the software, or it could be the manpower which were coming into picture. So that could be both ways. Okay, so these are the SSs which indicators basically which collect the evidence and also assign ratings. Okay, so this gives somewhat a picture about PAM model and PRM model in the A spice part. I'll also show a diagram. I think it's in the next one. Yeah. So here I'm going to show you the diagram where you can see like where I talked about in the process reference model, all of these things which are there, process ID, process name, process purpose and process outcomes. This will come in individual processes, which I'll show you in the next slide. And when you talk about process assessment model, it is talking about the overall view which we have. Okay, the PAM that whole document which will talk about what is the capability levels and what are there. So here we'll talk about the process reference model here. Okay, so this is the main process reference model, which you can see is following a V model. So I showed you, talked to you in the previous slide about SIS 1 to 5 and all of this. So here you can see how it is divided. So basically you can see everything is grouped into individual parts. First, we will talk about what I talked in the first or second slide maybe. What I told is like we have hardware engineering processes and machine learning processes included in this SPICE 4.0. So these are the things which were not there, these hardware engineering parts and the machine learning parts which were not there in the previous versions. And with the advent of industry 4.0 coming into picture, and how industry 4.0 is being implemented everywhere, and you cannot go ahead without having any AI capabilities implemented into your systems. So how industry 4.0 is also going ahead, making sure all of these interconnected systems are following are coming are being utilized. They are smart and also efficient at the same time, and there is what I can say, optimization. That is also one of the feature which all the industries look into. So similarly, ASPICE 4.0 also has taken that benchmark of including the hardware processes and machine learning processes. So what are the groupings? I'll just talk briefly. You have three kind of processes in the ASPICE. You have primary life cycle processes, then you have organizational life cycle processes, and then supporting life cycle processes. So what are the primary life cycle processes you can see? So all of this part is the primary life cycle process, where you have the system engineering process group, you have the software engineering process group, you have the hardware engineering process group, again you have machine learning process group also, and acquisition process group. I'll just talk in brief maybe about each of these process groups. So in the initial slides when I was talking about, so what I was telling you, you take it from the voice of customer, right? So in sys 1, what is mentioned, it's written that is requirements elicitation, right? So once you get the voice of customers from the whatever the customer may have, the customer may have a very a very simple requirement. Maybe when I open the gate of my car, maybe there should be a specific sound. This is for an example which I'm talking. Okay, so that could be just a requirement for us, for the customer. But when you have to implement into your system, you cannot write that in your requirement, right? You have to have a process or a way by which you will make sure that the requirement is in the technical standard. So you will have to see, like, okay, he is asking about a system to be implemented, so there has to be an automatic automated system inside that. There has to be again IoT coming into picture, so that the sensor, whatever is installed at the car gate. So it should be sensing that, okay, now I have been opened. So you write codes in MATLAB, right? Okay, when it signals, when it gets data that, okay, true or false, all of these kind of uh, what I can say, relational operations, you will go into those details, then only you can achieve this kind of a result. So where you, how do you do that? One customer voice that could actually come up into maybe 10 or even more requirements, because just the one sentence which your customer has talked about, like opening the door and you get a sound or whatever. So how do you do that? You have to have one team which will be making sure you get sensors installed, and you have to see, like, okay, certain sensor is there, it will collect data when you're opening or closing, and if that data is collected, so if it will go into a IoT kind of a thing, which will exactly assess at what time it's opening and when this music needs to be played. And you have to also ask a lot of queries to the person who is providing you this kind of a request, that whether you need it only in a single door, you need it on the all of the doors. So that is how requirements elicitation comes into picture. That is a whole process in itself. You could have that question, like, why again system engineering process group is having so many processes, sub processes within it. That is the reason I explained for the requirements elicitation. So again, in the next stage, it could be that you have written a lot of requirements, so they need to be mapped and seen whether they are at some level feasible or not. Okay, and you could probably, okay, get away with few of the requirements. Even if this is not done, we are meeting our our customer requirement, whatever it is, we could probably achieve it. And this certain requirement, so and so, is basically not required, we could remove it. So maybe in that requirement you add something which is specifically not needed. So this kind of reiteration will go into this analysis part in sys2. So once all of these is clarified and you are clear of what needs to be done, that is when sys3 will come into picture. So that is when you come into the architectural design part. Okay, you will design the architecture of what exactly needs to be done and how it needs to be connected within. And then finally you will have integration. So you will like, when you have so many of the requirements, when you design the architecture, that will be the whole thing. But you will be assigning these requirements to, like, it will be more like a smaller subsystems which will be executed by many engineers, and that needs to be integrated to bring into one specific system. That is what is happening in sys4. And the verification part also is done here once you have integrated all of the results and whatever you have done till now. And finally we go to verification. Okay, that is what one of the part where I have talked about system engineering process. So when I talked in the previous slide about process ID, process name, purpose, and outcomes in process reference model, so each of these, sys1, each sys2, they will have an individual process ID with their outcomes. I'm not going into that detail because I don't think so that is required at this stage. You need to know just like how the ASPICE 4.0 is in conjunction with the industry 4.0. At this point, I just want to get you a brief idea of how it is working, but the whole depth that is at, no, at this point I don't think it's required. But what you can understand at this point is each of these blocks which are there, the system requirement analysis, system architectural design, system integration, verification, they have their individual process ID where the base practices are defined for each of them. So if there is a requirements team which is there, so they have to make sure that what are the base practices provided in that document according to ASPICE 4.2, which needs to be executed. So they cannot deviate from whatever is mentioned there. So there could be something like uh, uh, what can be an example? Yeah, it could be something like the requirement should capture whatever is told by the customers in the technical uh, format, and it should be assessed in these so and so ratings. So that needs to be done. So there could be one engineer or two engineers who would be performing this kind of a operation. So that will be validated at some level, but that is what sys1 does. So similarly for sys2 also, you will have a different team, which it could be the same team also, it could be the different team, that depends on the organization. But that's how all of these things are executed. So at each stage it is made sure that there is no lag, or there is no scope for faults to go into the next process. That is how these processes have been designed in a space. Okay, so when I talk about primary life cycle process, it is pretty understandable that you have this as the main ones. For developing the product, these are the main process areas which you will be requiring. So there will be a system process which will be coming up with the system, whatever it is developing, verifying it and coming up with its results. There will be another software process group which will be designing whatever the .c files or the symlink files, whatever it is, and they will be again integrating that and coming up with the final results. Then there will be a hardware one which will taking up these results, or maybe they will be also they'll be maybe correlating with the software engineering group process also, and they will further go ahead with designing and seeing if you are verifying the requirements or not. The same thing goes on again for the machine learning or the acquisition. What acquisition is mostly, it's like checking into the supplier, like monitoring the supplier link. That is a different thing, but main things where the actual work is done into is these process areas. Okay, so validation obviously is one of the important part. Before you get it into field, you have to have the validation process group. So there is also some kind of interdependency which we see, though these processes all are working individually. When you come to system requirement analysis, when you come to system architectural design, so obviously, like when you are designing the architecture, you cannot take requirements from somewhere else. So you have to see that whatever the architecture is designed, you have to make sure that it can be mapped back to whatever the requirements you have with you already. So if there is any part of the architecture design which is not able to map back to the requirement, so then there is a lag. That is what we need to see. So this kind of traceability you have to also assess in these kind of places. Okay, is similarly if for software architecture design also. So whatever the architecture has been defined in the software, that will be used in the unit construction verification part. So if you cannot map those things, and that could be going backwards also again for software unit verification, it should be able to map back to the architecture design. So if these things are if there is some kind of what I can say, a gap which you observe, so that is a red flag which needs to be resolved at the earliest. Okay, so these are the primary life cycle processes. Then you have the organizational life cycle process. So obviously, we know in an organization, apart from whatever systems we develop and all, we need resources in the form of manpower and all of the things where there could be certain amount of risks could be taken again in certain cases. So how much of the risk we can take, and what is some of the process improvement group will be there. That is mostly that you can see here in the second part, PIM3. That is mostly like whatever the best practices you have followed here, like what you have come from this. Once you do all of this work, there could be some best practices that could be coming, that could come under this area of improvement, process improvement. So they could be also products which have been defined and designed, which could be come into reuse later for that same customer. So that is also a group which looks into all of that, and how it assesses, like if the product which is developed which could be used for reuse or not, that is assessed by this specific team. Okay, and finally, the supporting life cycle processes are the ones which will or depend on the other processes, that is the primary or the organizational life cycle processes. But they will make sure that whatever work is being done at this you know this place, if there is an issue or there is a defect that comes up, so how do you go about it and how it gets resolved? That kind of hierarchy and those kind of things are covered up in the supporting process group. Okay, I think I gave pretty much brief about what is the ASPICE 4.0 this thing. And here you have supply process group is the only part I think I didn't talk about. So this is basically comes at the last, when you have the release coming. So once all of this is adhered to and you have finally verified whatever you've done, that is where the supply process group comes into picture, where you finally send it for the product to be released. Okay, so this is something, and then I think we can go to the next slide. Okay, so here in the process categories, just like I mentioned, we have the definitions of what the primary life cycle processes, the supporting life cycle processes, and the organizational life cycle. So what I talked about primary life cycle processes, the main processes, that is, they consist of processes that may apply for an acquirer of products from a supplier, or may apply for product development when responding to stakeholder needs and delivering products, including the engineering processes needed for specification, design, implementation, integration, and verification. So that is my pretty much definition for it. But what I just talked about, so like whatever the supplier requirements will be there, how you develop the product, and how these needs of the customer or the stakeholder is coming into picture. So that is how you transform the voice of the customers to it could be some kind of a list, like a features list. There could be certain kind of features that they could want to ask, they would ask you to add into. So that could again be mapped into certain kind of capabilities which needs to be implemented to develop the product. And finally, this it also includes engineering processes which you need for specifying, designing, implementing, integrating, and verification. So I think this all of you all pretty much must be aware, like when you have .c files generated for each of the units you design for any of a product, you need to also integrate them at the end with a optimized .c file that will give you that you will give you the perfect result which could be verified. So if there is an organization which is using both this, the simulation and the code, they will probably go for maybe cross checking with both the results that come from the optimized C also, or C code also, and also from the final simulating model also. So all of these things are also coming into the verification part. Similarly, supporting life cycle process, what did I talk about? I talked about, I think, basically the configuration management, problem resolution management, change request management. So these are basically where the defects or any issues are being resolved. So it consists of processes that may be employed by any of the other processes at various points in the life cycle. So yeah, it's basically like in this whole primary life cycle process, there could be some issue that can be arised. So this is the supporting process group will be resolving. So this is a defect, then how the hierarchy, how it needs to be followed. Then again, for organizational life cycle process, it's a category which consists of processes that develop, process, product, and resource assets, which, when used by projects in the organization, may help the organization achieve its business goal. So that is pretty much the organizational life cycle processes which I talked about over here. Like they are mostly to cater to the business needs, where the higher level, the maybe the tier, what would I say, that the main group leader or whoever the boss is, they will be involved in this kind of activities mostly. So in my area, I work on all of these parts where where the system engineering process groups and software engineering process group comes into picture. So hardware is also there, and we are right now looking into implementing machine learning process groups also. Okay, in there you have the same way of taking the requirements, analyzing it, again generating an architecture, and having the training, that is training the set of data, whatever collected data is there. You have to train it, and then you have to test it. So these kind of things are also happening in the primary life cycle processes, which is again required. Okay. So in the organizational life process, all these decisions of what are the resource needs, what are the assets that needs to be counted, and all of these things are taken care of. So I'll quickly go. I think the already time. I'll just take maybe some much time, and then we can take some few questions maybe. So what are the process capability levels? I think in some of the previous slides I talked about how you have different capability levels for the process also. So when you have at a level 0, so it's an incomplete process. So the whole process, it is not achieving its purpose at all, then you will have it at level 0. Similarly, it is achieving its process, you will come at level 1. So it could be very easier to read this out, but when you implement the whole ASPICE process, it will be you'll be amazed to find out most of the organizations, even very it's very difficult even for them to reach the level 1 process. to attain that level also, it's difficult. You need to make sure of all the process outcomes, the base practice, everything is followed. The room for fault should be less. So when we come to level 2, it's the managed process. Okay, that is previously described performed process. It's when the performed process is already done, like in the level 1. So if it is achieving its purpose, then you have to see how it can be managed, that it can be bring into action, that is planned, monitored, and adjusted, and its work products are appropriately established, controlled, and maintained. So like sort of the organization has a proper way of maintaining these documents, whatever they are coming, how they are established, how they are controlled, and where it goes to. So all of these things, that's just an example. So it's basically bringing the perform process, that is a level 1, into action, that is happening in the level 2, that is a managed process. So once it's a managed process, you know that whatever the process purpose is being described, that has been achieved, and they have been also implementing it. So that becomes into an established process that goes into level 3. So it's now implemented using a defined process, and it's capable of achieving its process outcomes. That is what is written here. And then you have level 4, that is a predictable process, where now from the established process, it operates predictively within different defined limits to achieve its process outcomes. So that could be quantitative management needs which are identified, measurement data which are collected and analyzed. So it is more on the predictive part to see if there is corrective actions that could be catered, to see if there is any variations that are coming up. So this is more of a predictable process. So once this level is reached, you get into the innovating process. So if the predictable process is achieved by a certain organization, you can see how you can improve continuously to bring about the organizational change. Okay. So this is just a brief. I talked about like ASPICE 3.1, when you have similar to industrial evolution, which we have just seen. There are how the evolution in automotive SPICE has changed. So in the previous version, it was more software focused. The scope was limited. In 4.0, it's more broadened, and you have, just like I described, it's AI, ML, hardware, all of these things are there. So it's more aligned with the industry 4.0, which we have in picture right now, and the processes are very basic and traditional in the 3.1 part. And in 4.1, when we have software systems involved, it is also implementing the agile models, and also cyber aligned. So all the cyber requirements also are taken into consideration as in line with the industry 4.0 for ASPICE 4.0. And the assessment criteria or the methodology in the previous versions were limited, so there could be some gaps for any kind of faults to enter. But in 4.0, you have a requirement to have the docs, so everything needs to be formulated in a form of a strategy, and that has to be it has to be collated and kept somewhere. So the assessment methodology is much more stricter, and what you can say is much more uh, you know a disciplined approach is there in the 4.0 versions. So, what are the benefits of using this kind of standards in the industry, specific to automotive? In my case, it's used to reduce the defects and boost the quality or traceability. Like I talked about, like you have to see that you come to the next process, but it is in an alignment with the previous process. It is not wavering off from what has happened in the previous process. So it should not be like the boxes which we have seen, that everything is working individually. It's not like that. It should be coming in line with each other. So it also enables level 3 plus maturity for competitiveness and risks mitigation. So it's more like when you are coming into the market, the game, you have already a lot of industries coming at the, or a lot of organizations that are as four players in the automotive industry. So you have to cross a certain level. So it crosses the, when you are following express 4.0, so it crosses the the three levels for being the forerunners in the market, when you have this kind of an assessment done for your specific whatever product or whatever thing you are as a designing. Okay? And they did in complex projects, yeah, obviously, like where you have the whole automotive system is software driven, and you have a lot of processes involved, and where there are a lot of teams involved. When you have a process like this, it when this is followed by each and every process group, the risk is obviously reduced to a lot of extent. And this I just wanted to show because I talked about traceability just before in that previous slide. I wanted to show like, okay, what are the synergies between ASPICE 4.0 and Industry 4.0. So it handles AI, ML complexity in connected cars. It is also using real-time IoT data as you use in factories, and the traceability is also the in cybersecurity, which is there for smart supply chain. That is also coming into picture when you come into ASPICE 4. So where I showed in the previous slide that the system requirement, system architecture is there. So this is the direct stakeholder requirement. That is the voice of customers, which I was talking about since the beginning. So that has been interpreted as a system requirement. So you cannot just use them. So how you see the traceability here? You can see that the system requirements are the one which depends which are required for designing the architecture. Similarly, the architecture, whatever is being designed, it should be mapped from the requirements itself. So it's bi-directional. You can see everywhere. Even for the system requirements, they are again used as a part of the software requirements also. So they everything should be mapped. So similarly, again, you have a software detailed design. There cannot be a detailed design without using any of the requirements. So each of the detailed design needs to be mapped to the requirements. So these all things are like bi-directional. So whatever verification measures you are using, so that should utilize all of the units that have been developed, all of the .c files, for example, it should come into. That is not like one of the .c file is missed. So that is how the verification measures will make sure that everything is mapped into it. So there will be a bi-directional traceability here. The same thing is being shown for all of the other process areas also. Okay. And when you see here change request, it's basically for the issues. Okay. So when there are any probable reports is what is mentioned, probable any errors which could be coming up. So there will be some kind of request which will be raised to change or to make some modifications, and that will be checked for what are the work products which will be affected, like what maybe it will be affecting the system requirements, maybe it will be affecting the software architecture. So that is collated, and that will again be checked on to where it could be provided in this whole of the box of the primary process areas. So this is just to show like how now industry 4.0 also everything is interconnected, and it is made sure that the dependency is foolproof. Even in ASPICE 4.0 we follow that same methodology. So basically, what are the challenges and solutions? If you have to see, the challenges is obviously the integration. So there are a lot of uh, integrations which I showed you, like where you have the software integration, you have the system integration, you have the machine learning integration, hardware integrations. All of these, how do you mitigate in ASPICE 4.0? You're using the revised PAM models or the PRM models and the process assessment models. Okay, so for how it is augmenting or enhancing the industry 4.0, so you are using IoT devices that can be scalable. So because the integration part is the challenging thing when you are bringing a standardized process into it with assessment models. It is bringing products which could be scalable and which are not having any errors. So that could be a scalable IoT in the industry 4.0 field. So when security is coming into picture, we again have an ISO for that. That is 21434. That mapping is also done, and that makes sure that there is a security provided. So that also is a benefit in the industry 4.0. And agility is like you are using agile process for the support, for the supporting process activities and organizational activities. So that kind of a process also, yeah, brings about more innovation and optimizes the process to a larger extent. So that is another benefit which comes to when we look at the larger perspective of industry 4.0. Finally, I would like to conclude my presentation. I think there could be a lot which could be covered, but I kept it as much as possible to short to cover. It is ASPICE 4.0 powers industry 4.0 ready automotive development, and it aims for higher maturity so that you have smart mobility. Okay, and this ASPICE automotive spice process assessment model, that is what is having a set of indicators which will interpret how what is the intent of the model or the process model which you are using in your specific case. Okay, so that is how ASPICE is driving industrial revolution, specifically in the 4.0 era with smart mobility. Okay, I think I would like to conclude. If there are any questions, we can take it right now. So we have some more time.
Professor Kundu, is there any question in the chat box? You please check. In the meantime, I have certain queries.
Yes.
First and foremost, let me tell you, Dr. Tamanda, it has been an excellent presentation. Excellent
Yes.
presentation in the sense, I understand it is just an year-old platform that has been released, I think.
Yeah.
Because
Yes, sir. December
so
2024.
23, yeah. So
20,
it is just 1 year old
yeah.
and or 2 years
24.
old.
No,
Oh,
24.
okay. So
Yeah.
if that is the case, I mean, I believe that it is extremely comprehensive, and in the automotive space, several of the uh, I 4.0 issues will be resolved or
Yes.
can be implemented very easily. My
Yeah.
only query is rather,
Hmm.
does it also include some aspect of the design of the automotives in some way?
Yeah, sir. Like the design is
Like say, for
coming.
example,
Yeah.
okay, I don't know. I just wanted to know this surface thing. Like say, for example, does it consider, like say, first and foremost, does it have the import capability
Hmm.
from, say, for example, Simulic Advisor to get the driving cycles?
Yeah. It has that capabilities. And all of those, like the best part of this automotive spice
So
specifically is that.
all these driving cycles like UDDS, HWFET,
Yeah.
or NADC,
Yeah.
all it can import.
Yeah. It can import and you
Oh,
can.
that's great. That's great. That's so
Yeah.
wonderful. I mean, if
Yeah.
that
You.
is that capability it has,
Hmm.
then this is fantastic. You are getting a great opportunity to work on this.
And
It's a
also.
wonderful opportunity.
And it's also like, sir, it also like takes all the data from even the few things which we discussed a lot of time before, like the design methods, like the failure mode effective analysis, effect
Oh, that
analysis,
also it takes
DF.
FMEA,
Yeah, so it
FMEA or FMEA.
yeah.
Okay,
So all of
okay.
these FMEA, DFMA, and all of those capabilities are also considered in this
So
thing. So
nice.
yeah. So it's a, like a
Okay.
very on the higher level, it takes up from direct from the voice of customer even till the verification part with
And I'm
each and
sure
every.
it has the concurrent engine capability because multiple location, multiple types of disciplines working together.
Yes. Yeah, that is maintained with all the teams. Yeah.
That's great. I mean, one changes in one place actually is accommodated in other places as well.
Yes, sir. That has to be accounted
Yeah,
in, or else
it's a
that is the
this
main part which I was talking about in traceability. So
no.
the
I'm
mapping
really
has to be.
impressed. I'm really impressed that since um, uh, I 4.0 was actually from the Germany. This also is, I believe, is a German product. So
Hmm.
they are actually very much into this industry 4.0.
Yes.
And it is good that we are doing it.
Yes.
India will have this opportunity because not many people are actually delivering programs on I 4.0. It is a very
Hmm.
comprehensive or assimilation of several emerging technologies. That's why we targeted.
Yes.
And this presentation is very much in sync.
Hmm.
Absolutely. I mean, say end to end. That was very impressive.
Yeah.
Absolutely end to end.
Yeah.
Great.
Thank you, sir.
Good. Excellent. Thank you
Thank
very
you.
much. Thank you very
Thank
much
you.
for your presentation.
Thank you.
Sir, I like to mention that one question is present in the chat box.
Yeah.
That's Professor Uttulendu Mondol is asking that how does ASPICE mitigate the risk of critical projects?
Okay. So I think we'll go to this thing. Yeah. So when we are talking about risk mitigation, so obviously when I talked about the how you are taking the requirements and analyzing it, you are designing it. So at all of these levels, you will, because I have not showed you specifically in the space of time. I have not showed you when you are talking about base practices. So it is already having for the system integration and integration verification for specific to be specific. So they will be having already certain kind of process outcomes or what you can say, some kind of base practices which need to be provided. So you have to see, like, you have to, if for example I will provide something like ensure unique identification of this verification details, or you have to map it to something, those things which when you are obviously trying to implement these base practices, in sys 4 specifically I will try to say here in sys 4, where these are the areas where sys 4 and SWE 5, these are the areas where the risks could probably come up. Even in for hardware, when you are verifying it against hardware design, there are the parts where you get the, when I talk about risk, it's more about the issues which could crop up. And if so for a very simpler example I will give. So okay, if the customer has come up with the example which I talked about of opening of a music being played when you open the car gate. So it could be like when you are generating a lot of .c files and you integrate it, maybe the optimized .c file gives you the perfect result, and it's also being able to give the result. But the same .c file, when you are doing in your Simulink model, and all of these small Simulink models are integrated, maybe individual models will be giving perfect results, but when you integrate them and when you get the bigger model and you try to run the results, maybe there could be some error. So you have to again go back to that specific team. So that team could be from any of these teams, that could be from the requirement also, there could be an error, or there could be an error from the architectural design. So once you run those things, you will get to know where the error is, and you have to go back again to those specific teams to make sure that those errors get resolved, and again you do this specific run. And just like the optimized C code also generates a result, the whole integrated Simulink model also generates a result. So again have an opportunity here to cross check from both the ways. That is what is you can say what we call as the back to back testing. So where we make sure that any kind of error, there is no room for that, and that is how the risks are basically mitigated. And each of these process areas, even the teams, uh, maybe they are not falling, but once it comes to the ASPICE 4.0 purview, we do make sure that all the base practices which are there mentioned for each of these sub boxes, that is adhered to and stayed. So that is how the risks are mitigated. I hope I could answer the question. Hello. Hello. Am I audible?
Yes, yes.
Yeah. I think.
Uh,
There is no more question, madam.
Okay. Yeah.
If anybody intends to ask a question, can ask also, in
Yeah,
voice.
offline, I'm always there. Yeah, I'm always there. You can
When the
connect me
voice,
on LinkedIn. LinkedIn also. Yeah. Yeah.
yeah. No, in voice, one can ask the question now if they
Yeah.
want,
Sure.
or
Hello, madam.
Yeah.
Madam,
Yes.
I am asking one question. What is the basic difference between energy conservation and energy efficiency? Efficiency and conservation in the first portion of your dictation.
My slides.
Energy conservation and energy efficiency. মানে using
Like
of the
energy.
efficiency. In case
Yeah.
of the practical life, it is using whatever is using, that is efficiency. But
Yeah.
conservation and efficiency, that means is it interrelated or differentiated, or basically in which point we can
No,
differentiate it?
conservation. You're saying energy conservation, right?
Conservation and efficiency.
Yeah, I think both are somewhat related, because once you, are using any measures to conserve the energy, then only you can probably go into making the system energy efficient also. So the efficiency comes later once you are able to, conserve the energy. So that is somewhat related only. Yeah.
Madam, it is the relationship, but basic difference, মানে code difference. I am not understanding it properly. What is the code difference between the conservation and efficiency?
Yeah,
Basic
like,
difference.
no, in conservation, or mostly it is, how you could be using, or some mechanisms, or some tools or some processes by which you can probably reduce, the energy usage. Is what I understand through energy conservation, and that is what is the main objective in when we talk about energy conservation. But when we are talking about efficiency, the conservation could be just a small subset, but we are also looking into ways how we can improve the efficiency of that particular model or vehicle, where in an automotive system the efficiency could be probably realized if we are using lesser number of actuators, or
Yeah,
any kind
that
of
I think is the best expression. It is a subset of that. Yeah, yeah, that is the
yeah,
right
subset,
subset of that.
right?
Yeah.
Yeah,
Okay,
yeah,
madam. Okay, thank you, madam.
right.
Thank you.
Thank you. Okay, so then I think we are done.
Yes, Dr. Nanda, you are done, but Professor Roy will be concluding it formally. So,
Yeah,
yeah.
sure.
Yes, sir. So if no more question is there, now I'm going to conclude. So thank you, Dr. Tamada.
Yeah,
Your
thank you.
nice and presentation. It is a wonderful session for the participant. So thank you very much. So tomorrow we have session. It will be starting from 2 p.m. So all participants requested to join at that time. So thank you very much.
Yeah, thank you, thank you, thank you,
Thank you.
thank you all.
Thank
Yeah,
you. Thank you.
you.
Thank you, and good night. Yeah.
Good night.
Yeah, good night.
Okay, all participants, before leaving the meeting, everyone must fill up the feedback form that I have given in the chat box. And I am also shared the question bank for tomorrow's exam in the WhatsApp group. Thank you very much.